Hello, Algebra 2 students. Today we're going to be taking a look at an answer to this critical question of how do I solve a quadratic equation by taking a square root? So this is the key question for today, is how do we use those square roots, that button, that operation, in order to solve an equation that we know has two solutions, a quadratic equation. So you're going to need your notes, a calculator, and something to write with. So what we've been talking about are quadratic equations. Those are equations that have an x squared in them. So notice the difference between 3x plus 4 equals 16, 3x squared plus 4 equals 316, or equals 16. So the x squared changes the way we go about thinking about solving. That's why we were talking about factoring. When factoring helped us was when we had an x squared in the problem. So notice the difference here between problems we've been working on with factoring, x squared minus x minus 6 equals 0, versus a problem that we would use solving by a square root, x squared minus 6. Notice the difference there. The first one, you have an x term. You have an x in between the x squared and the 6. The fact that x is located in two places, we have an x squared and a regular x here, this idea lends itself nicely to factoring. Whereas over here, there is no x term. In fact, here is the x, one location, one spot. So when we want to go about isolating it or solving it, we know how to do that. In fact, you spent a great deal of time last year dealing with these types of problems when you did the Pythagorean theorem. You solved for x squared, you solved for x. So today, here's where our notes begin. Let's go about solving this type of problem where we have 3x squared plus 5 equals 41. Now, in order to get the x alone, that's what it means to solve. Here he is. We need to go about doing inverse operations. So listen to your gut here. You have some algebra skills. We're going to go ahead and subtract 5. 3x squared equals 36. Now we need to get the 3 away from that x squared. So we're going to divide. X squared equals 12. And now we go ahead and get the squared away from the x. Okay, to undo the operation of squaring or taking a power, you do the root. So here we're going to go ahead and square root both sides. So x would be the square root of 12. Now be careful, we actually have two solutions. So we're going to place a plus or minus sign here ahead of the square root of 12. When you take a square root, you're asking yourself what multiplies by itself to make 12. So you're going to have two answers. Two positive numbers can do that as well as two negative numbers. So we get two solutions. That's why the plus or minus is there. Now, with the whole square root of 12 business, remember from last year, you simplified these square roots. We do not want to write a decimal approximation. So don't go to your calculator and type in the square root of 12 and write me the decimal. Okay, we want to actually figure out what this looks like in simplified form. To do this, we're going to simplify your square root. Remember, last year you talked quite extensively about perfect squares, as well as in Algebra 1 you talked about perfect squares. These are numbers that you know the square root of. So when we look to simplify the square root of 12, we're going to simplify him by breaking him apart into two numbers, one of which has to be a perfect square. So 12 is the same thing as 4 times 3. The square root of 4 times the square root of 3 is the same thing as the square root of 12. Now if I simplify what I have, it is plus or minus. The square root of 4 is just 2. The square root of 3 I'm going to leave as the square root of 3. So x equals positive or negative 2 square roots of 3. This idea of simplifying the square root, I know you did quite a bit when you took geometry. So let's look at the second one. Go ahead and listen to our gut here and add the 15. 2x squared equals 80. Then I'm going to divide by 2. X squared equals 40. And last but not least, I'm going to square root plus or minus the square root of 40. And then I'll break apart the 40 into 4 times 10. 4 is a perfect square, so it's 2 square roots of 10. So plus or minus 2 square roots of 10 is what the x equals. And example 3, I'm going to add the 5. 4x squared equals 14. Then I'm going to divide by 4. X squared equals, I'm going to leave this as 14 over 4. Okay, 14 over 4, just fine. Don't divide it out. Don't write a decimal, because when we go ahead and square root this, when you square root a fraction, you square root the top, the numerator, and you square root the denominator. So if I take the square root of 14, I don't know what that is, and it's not a perfect square, and it can't be broken apart by any perfect squares. So I'm just going to leave him. And if I also look at the denominator, that was a square root of 4, that is just 2. So I would go ahead and leave my answer just like this, plus or minus the square root of 14 over 2. And solving number 4. This one's a little bit more complicated. Now, sometimes people want to distribute or multiply here. Remember, our goal is to try to get x alone. Distributing, and that doesn't really help me. Plus, I don't really want to write x minus 2 times x minus 2, which is really what's happening when it's squared. You cannot distribute the squared. Okay, that's not how it works. That's not what it means. So I don't really want to multiply all this out and then take that answer. That doesn't really sound too fun. So what I'm going to do instead is working on these inverse operations. Go ahead and get rid of things. Use our inverse operations to make this problem look a little nicer. 39 plus 1 is 40. I have 3 times x minus 2 squared. And now that 3 that's in front, I'm going to go ahead and divide by the 3. So I have x minus 2 squared equals 40 over 3. And now I'm going to go ahead here and I'm going to square root. Because the x and the minus 2 are both trapped in those parentheses being squared, I need to square root in order to free them, if you will. So I have x minus 2, and then on this side I'll have plus or minus the square root of 40, which we've already simplified earlier into 2 square roots of 10 over a square root of 3. Okay, now what you might have remembered from geometry as well last year is that you cannot have a square root in the bottom of your fractions. In the denominator, it's not okay. So we're going to do what's called rationalizing the denominator. The thing that you have in the bottom of the square root is a square root of 3. I'm going to go ahead and multiply both the numerator and denominator by the square root of 3. It's a fancy form of 1. This is the same thing as 1, so I'm not changing the fraction's value at all. I'm just going to change the way he looks so that square root is no longer in there. When I do that, when I go ahead and I multiply it by that, the 2 hanging out in front still there. The square root of 3 times the square root of 10 becomes square root of 30. And then on the bottom here, square root of 3 times square root of 3, that's square root of 9. Well, that's just the number 3. Square root of 3, or square root of 9 is just 3. So this sort of fraction thing without the square root in the bottom turns into this guy. Plus or minus 2 square roots of 30 over 3. So far this is what we have. X minus 2 equals plus or minus 2 square roots of 30 over 3. And then I'm going to go ahead now and take a look at what else I have to do to get the x alone. This x is x minus 2, so I'm going to add 2 to the other side. So it becomes x equals 2 plus or minus 2 square roots of 30 over 3. That's my final answer. There's a lot of steps involved here. A lot of going on, knowing how to simplify a radical, knowing how to rationalize the denominator, knowing how to put the plus or minus in the problem. There's a lot of things to keep in mind. So be thinking about all these things tomorrow when you come, and we'll get some more practice on that.